Good evening, class. I'm Santosh Takale. Today's class will be taken by Prajakta Madam. It will be physics, and you all know that already we have completed 30 plus lectures, and we will be continuing through your 11th, then holidays in between 11th, 12th, and till 12th if you show right response. Normally, today's class strength, nowadays class strength is around 10 to 15. Okay, it's very less, and it sometimes hurts teachers that why so less student when the classes are being taken very nicely. So, if possible, be present for every class. Keep revising. Prajakta madam is present, so she will continue. Okay. She was
Yes.
busy with the madam. Yeah, madam, please continue.
Yeah, I hope you can hear me.
Yes, ma'am.
Yeah, I let me just share the screen. So sorry for the delay in the joining. I had another meeting scheduled right before this.
Yes, madam. No problem. Please continue. Your screen is visible.
Yeah. Okay. Great.
Thank you.
Um. Yeah. Yeah. So yeah. So in the last class, we had started this chapter, the superposition of waves chapter, and then we had looked at we had basically quickly looked at what are the kinds of mechanical waves that we're talking about. um, and then two different types, transverse and longitudinal waves. And we had seen like functional form, for example, here. And then we had moved on to checking the reflection of transverse waves and reflections of longitudinal waves. So we had basically then made this table. Ki if a transverse wave is getting reflected from denser medium, then it will be the crest of the transverse wave will be reflected as a trough, and the trough will be reflected as a crest. Whereas if it's getting reflected from a rarer medium, then it will be the crest will remain crest, and then the trough will remain trough. And similarly for longitudinal waves, we had also seen key if it is getting reflected from denser medium, then the crest will the not the crest but the compression. So the compression will remain compression, and the rarefaction will remain rarefaction. But if it is getting reflected from the rarer medium, then for longitudinal waves, then the compression will get reflected as rarefaction, and the rarefaction will get reflected as compression. So this is something we had seen in the last class. And then we had also look very in a fast paced manner, looked at what is superposition, like the conceptual part of superposition of waves. So I will just quickly maybe reiterate what we had looked at so that we can look at this in the more mathematical form in today's class. So what this essentially is saying, essentially, firstly, what happens to a particle of a medium when a wave passes through is, let's say this is some medium, just may say there's some transverse wave that is passing, and let's focus on this particular particle. So every medium is made up of some small molecules or whatever particles. um, and then this one particle, we can essentially say that each particle of this medium is performing an SHM on its own. So when the wave passes through that particle, so if we look at this one particular particle here, then we can see कि जब wave यहाँ से pass हो जाएगी, तब this particle will first maybe move in the top position, which is the positive maximum. Then after some point, it will come to the center, then go to negative maximum, and then go to center again. And this is how, through collective SHM motion of all the particles of medium, the wave will propagate forward. So for a wave to propagate, you need oscillations of medium, or like particles of medium. Particles of medium for a mechanical wave to travel, or yeah, travel. So essentially, every mechanical wave will pass because of each particle of the medium is oscillating about its mean position. So this particle is not going to move this way. So it is not, let's say this is the x-axis and this is the y-axis. So each particle, so the wave is moving in x direction, wave is moving in positive x direction, but the oscillations of particles is always going to be in the y-axis direction. So the particles are going to always oscillate perpendicular to the motion of the wave, which is the definition of transverse wave. So by definition, transverse wave is the wave in which particles travel in a perpendicular direction to the motion of the wave or the direction of the wave. And similar things will happen also for rarefaction. So rarefaction, in rarefaction, you'll have parallel motion. So this particle will essentially move in a parallel. So this is the direction of wave, and this is the particle. So it is going to be oscillating in a parallel direction to the motion of the wave. So when this happens, and then this is a single wave. So we have one wave. So now let's say ki, this is a medium, and this is a particle of some medium, and through this particle now simultaneously two waves are passing. So let's say this is one wave that is coming in from this direction, and this is another wave that is coming from this direction, and this particle is getting subjected to both the waves simultaneously. And now that is so to find the resultant motion of this particle in such a case is basically to study the superposition of waves. And what we had learned in the last class is the principle of superposition. Um, Principle of superposition, which basically says कि if you have such a condition where two waves are simultaneously crossing a point in the medium, then each wave passes as if the other wave does not exist, and the displacement of the particle is the vectorial sum of the displacement that is caused by both waves individually. तो मीनिंग क्या है इसका? So just to read the formal principle or like the formal wording of this, we sorry not here. Yeah, we have here, which is when two or more waves traveling through a medium pass through a common point, each wave produces its own displacement at the point independent of the presence of other wave, and the resultant displacement is the vector sum of displacements due to individual waves. So what this means essentially, ki let's say this is wave 1, and then we have this wave 2 coming from the other direction, which may it probably has like a longer wavelength, let's say, some different property, or it might be also same wave but coming in different direction. And this is the particle of the motion. Now I'm just going to draw this here. So this is original particle, and let's say at t is equal to 0, the particle is at the mean position. Now at t is equal to 1, the particle gets acted upon by both wave 1 and wave 2. Now we can just see what is the individual effect of wave 1 and wave 2. Let's see, wave 1 takes this particle from its mean position to this displacement d1. So this is the effect of wave 1. And let's say if wave 2 had hit the particle independently, then it would have displaced the particle by some different this thing, which is d2, and this is the effect of wave 2. तो द प्रिंसिपल ऑफ सुपरपोजिशन बोलता क्या है इसेंशियली कि अगर दो वेव्स एक पार्टिकल को सेम टाइम पे हिट कर रहे हैं, तो उनका जो डिस्प्लेसमेंट होगा, दैट पार्टिकल का डिस्प्लेसमेंट, दैट विल बी द वेक्टर सम of displacements that will be caused because of individual waves. So इस केस में individual displacements of wave 1 is equal to d1. This is a vector because if you see, it has direction, obviously, because this is the positive direction and this is the negative direction, right? So in that sense, it is a vector quantity. And then individual displacement because of wave 2 is equal to d2. So now the combined displacement of particle because of wave 1 plus wave 2, let's say the combined displacement is capital D, and that is just going to be vector sum. So d1 plus d2. और इसको अगर पिक्टोरियली रिप्रेजेंट करना है तो वी कैन से कि wave 1 change this particle to here. So this is our particle and this is the effect of wave 1. So this is the axis, and then the same particle would have been displaced by this amount, this small amount, by wave 2. So this is wave 2. तो जब वेव 1 और 2 दोनों साइमल्टेनियसली पार्टिकल को हिट करेंगे तब it will just be the sum of these two displacements, and let's say this is here and then maybe till here. So the combined displacement will maybe something like this. So this is the wave 1 plus wave 2 effect. Similarly, if we now say कि wave 1 का displacement is this, but the wave 2 displaces the particle in the negative direction. So this is the wave 2 का displacement. This is wave 2. तो because this is a vector sum, तो इसका बस स्केलर एडिशन नहीं होगा बल्कि इसका सब्ट्रैक्शन होगा, because this is a positive quantity and this is a negative quantity. So subtraction करने के बाद we will probably get some amplitude like this, or maybe like something like this. So this is the effect of wave 1 plus wave 2. So I hope like the concept is this basically. Superposition is just the vectorial addition or vector addition of the amplitudes of these two waves. And then we will now come to like a more mathematical description, and this is also where they have given like a better picture. So this is a wave that is coming from this direction and this is the wave that is coming from that direction. The amplitudes of these waves are exactly same, but they're traveling in the opposite directions. तो यहाँ पे हम देख सकते हैं कि this is the dotted lines is the position or like the wave before superposition happens, or without superposition, and then this is this will change the pen color, and this is the wave. This is how it will look. There will be small bump here because it is getting added up. Essentially, the amplitudes of two superposing waves are getting added up, and then this wave will then pass in this direction, and then the next wave will pass in that direction, and now there is no effect. So these are individual waves again. Similarly, this is another case. So this case where two waves are traveling, they make the amplitude change in the same direction. So this is also positive displacement and this is also positive displacement. And in that case, we see the addition of two displacements. So d1 plus d2, just direct addition, scalar addition. So this case is called constructive superposition, because it is an addition, so the amplitude always increases. So the constructive superposition में amplitude of resultant wave is always going to be greater, or I mean it is always going to be greater actually than the amplitude of individual waves. Okay, so that is constructive superposition, and in this case one amplitude is positive and other amplitude is negative. So the resulting amplitude is essentially the subtraction of two amplitudes. And in that case, the resultant amplitude is going to be less than the individual amplitudes. So and this is called as destructive superposition. So destructive superposition में amplitude of resultant wave is always going to be less than amplitude of individual waves. Okay. So we will learn this in a more like mathematical. So the things that I wrote here, key d1 plus d2 and d1 minus d2, we are going to see the derivation of these. But this is essentially the concept of constructive and destructive this thing. And यहाँ पे इस पिक्चर में हम देख सकते हैं कि destructive interference का description. So this is one wave with positive displacement, and then this is another wave coming in the opposite direction with negative displacement. तो जब ये दोनों एक दूसरे के ऊपर सुपरपोज हो जाते हैं, when they are at the same position, both of the waves, then you can see ki, this is the original wave of positive displacement and this is the original wave of negative displacement. But because now they are at the same position in a superposed manner, you will see a flat line which is no displacement because their amplitudes are same but opposite in direction, and they now cancel each other out. So that is destructive interference. They look like normal two waves. So so that is destructive interference. So I found a good, like a good YouTube video to show the constructive and destructive this thing. So we'll just probably look at that. I hope you can see the screen. So what these people are doing essentially, this is a string in the video. This is the string, and they have kept these glass paper glasses at the amplitude of the wave. So you'll see कि ये दो जो लोग हैं, they try to disturb this wave and make a wave out of this string. And let's probably just see what they're showing. So you can observe what is happening here in the slow motion. So this is the wave that is passing, and this is the another wave that is passing. So if you see, maybe I'll go back. So one wave, and then it is getting reflected. So this is one wave, and this is another wave. So essentially, the wave we saw here, this is one wave, and this is another wave. So same way में, these are two waves. So if you can see, the paper boxes are kept at a height which is more than the amplitude. So this is the amplitude of first wave, and this is the amplitude of second wave. I hope you can see my cursor though. And then the paper boxes are kept at a amplitude which is higher than the amplitude of these waves. But now you will see कि they are coming at the same position and they are getting superimposed. And because they are both have positive amplitudes, their amplitudes are just getting added up. And because their amplitudes are getting added up at this position, this particular position, the paper glass at this position is just getting thrown away. If you see carefully, see, yeah. So no other paper glass is affected, but that specific glass at the position where the superimposition happens, that box gets thrown away. Yeah. So this is how the constructive interference will essentially increase the amplitude of the wave at the location where the superposition is happening. And now this is a example of destructive interference. So in this case, you're seeing the exact opposite thing. So these two waves are coming together. और इस केस में जो पेपर ग्लासेस रखे हुए हैं, they are kept at a distance which is lower than the amplitude of both the waves. तो सारे जो पेपर ग्लासेस है, they will be distracted by the wave that is coming, because this is the amplitude and this is where the glasses are kept, except for this one glass which is kept at the exact point where the destructive interference happens. And because ये दोनों waves का amplitude same but in the opposite direction है, so when the two waves come at same point, they are going to cancel each other out. And because they cancel each other out, there is not going to be any displacement that will throw away this paper glass. So ये एक ही पेपर ग्लास है जो it's not getting moved from its position, but all other paper glasses are getting thrown away. So I think this is a very neat demonstration of constructive and destructive superposition. Just one more time. Yeah. And I will put the link to both the YouTube videos. Good demonstrations actually. So this was just the conceptual understanding of what is constructive superposition and destructive superposition. And now we are going to formally look at the derivation of the resultant amplitudes and the resultant motion essentially. So the next point will be the amplitude of resultant wave produced due to superposition of two waves. Now, if you remember, we had done something similar. Like once you see the derivation, it will probably click in your mind that we had done a similar derivation in the last chapter as well, which was also called the superposition of two SHMs. At that time, it was superposition of two SHMs, and now it is superposition of two waves. But the derivation is very similar, and the result is also very similar to what we had derived earlier. So you can probably go back and check that derivation also and see how that compares with this derivation. Um, so resultant motion of superimposed waves. So we can consider two waves which are coming to same point in the medium simultaneously. So we can write y1 as a1 sine omega t, and y2 is the wave with different amplitude. So a1 and a2 are different, but it has the same omega. So the frequency stays the same. So we are only calculating this result for a limited case where the frequency of both the waves is the same. Um, and then there is a phase difference between this wave. So one wave is at phase difference of 5 degrees from the other wave, and they are arriving at the same point at the same time. So as we saw from the principle of superposition, which is that the resultant amplitude, let's call it y, is just going to be vector sum of the individual displacements of the particles or individual motions essentially. So we are going to just open these sine and cos things. So y1 is a1 sine omega t plus y2 is a2 sine omega t plus phi. And if you remember in one of the earlier classes, we had used um, this trigonometric identity, which is that sine a plus b is equal to sine a cos b plus cos A sin B. So we are going to open this sin omega t plus phi in that same manner. So this will be A1 sin omega t plus A2 sin omega t cos phi plus sin no, plus cos omega t sin phi. And now the variable here is t. So t is the variable in all cases, and the phi terms, cos phi, sin phi, these terms are going to be constant. So we need to collect the terms with similar variables. So similar as in sin omega t, sin omega t. These terms will be collected, and then the cos omega t will stay separate. And then this will be collecting the sin omega t terms. We'll have a1 plus a2, this a2, and sin omega t cos phi. So a2 cos phi into sin omega t. So this will be a1 sin omega t and then a2 cos phi sin omega t plus a2 sin phi cos omega t. This term over here. Okay. Now we can assume we can let a1 plus a2. So these are all constants. Okay. Ki a1 is constant value, a2 amplitude of second wave is constant, and the phase difference. So cos of phase difference is also constant. So these are all going to be constant values. And because of that, we can just take this whole term of constant values and name it or like call it some other constant value, and we are just exactly going to do that. So a2 cos phi, we are going to assume that this value is equal to a cos theta, and a is going to be essentially the resultant displacement or resultant amplitude of the superposition of these two waves. And this is also going to be a constant. So this theta is also going to be a constant. So one constant is equal to some other constant is just renaming the variables, and that is perfectly fine. And similarly, we are also going to take this a2 sine phi. This is also a constant term, and we are going to say that this is a sine theta. Um, and then we can write this equation of y. If you remember, this is exactly the same steps that we had followed in the last chapter wala derivation. So you can also revisit that derivation. So this term will be replaced by a cos theta, and this will be a cos theta sine omega t plus a sine theta cos omega t. And this is again cos a sine b plus sine a cos b, same thing, and that is just going to be equal to by this same formula. This is also going to be equal to a sine of omega t plus theta. So the resultant y is essentially going to be a sine omega of t plus theta. So this is the resultant motion of superposition. Resultant motion of y1 plus y2. And if you see, this is also a SHM motion, also SHM, um, with amplitude is equal to a, and the phase difference in the resultant SHM is equal to theta. And we can find these values now. So we are going to do that. So we want to find A, and A we can also write this thing as um, A square sine square theta plus A square cos square theta. Because sine square plus cos square is just going to be 1, and then it will be root of A square, which is A. But then we have these values, which is a sine theta and a cos theta. So we are going to substitute that here. And that will be root of a square sine square theta will be is equal to the square of this, and then the square of this we'll write that now. So that will be a2 square sine square phi. So don't get confused between theta and phi. I'm writing this line bigger so that you don't get confused there. And then a square cos square theta is just going to be square of this whole term, which is going to be a1 square plus a2 square cos square phi plus 2a1 a2 cos phi. We have just opened the a plus b bracket square. And now again we have a2 square sine square phi and a2 square cos square phi. So this cos square phi and sine square phi addition is going to be 1, and we can just write this as a2 square plus a1 square plus 2a1 a2 cos phi. And this is going to be the resultant displacement in case of superposition. I will just highlight this. Yeah. And now if you now we can think about like constructive difference, constructive superposition and destructive superposition. So constructive superposition may we will always have I'm just going to write the this much. So constructive superposition happens when two waves are in phase. What that means is phase difference phi is equal to 0, right? And because these both waves, they appear at this point simultaneously. So this is one wave and this is another wave. So they appear at same point simultaneously, which is what we mean by saying ki they are in phase. and the phase difference is 0. So if we put this phase difference 0 here, we will see ki phase difference 0 meaning cos of 0 is 1, and and so the resultant A is just going to be equal to a1 square plus a2 square plus 2a1 a2, and this whole thing is just going to be a1 plus a2 bracket square, and then taking square root of that we are going to get a1 plus a2. So this is what I had written over here. The displacements are just going to be sum of individual displacements in case of constructive interference. And now similarly, if we want to look at the destructive interference, then in destructive interference, the waves are going to be out of phase. And by out of phase, I mean कि जो phase difference होगा उनके बीच का, that will be 180. So, so if you see here, so this wave comes at this position. This wave is in totally positive amplitude, the maximum amplitude in positive direction, and the next wave is at the maximum amplitude but in the negative direction. So this is the phase difference. This is the phase difference of 180 degrees, or pi radian. So that is when the destructive interference happens. And if we now put this 180 ka phase difference into this equation, then cos of 180 is going to be minus 1. Cos of pi is minus 1. So the um, resultant amplitude is going to be a1 square plus a2 square, and this will be minus 1. So this sign is going to be flipped, and so that will be 2a1 a2 minus 2a1 a2, and then this is going to be a1 square minus 2a1 a2 plus a2 square is just going to be a1 minus a2 bracket square, and then the square root will be taken because of the square root sign, and then this is just going to be a1 minus a2, the mod of it, because the uh, square root will always give you positive values. So this is going to be, so this is what I had mentioned here, um, which is that the resultant amplitude will be difference of individual magnitudes. So that is constructive and destructive interference in terms of like this specific equation. So this is exactly the same equation that we had gotten in last class also, last chapter, sorry. And then we found A, and this is the A essentially which is given here, and these are the special cases, which basically say that the resultant amplitude is maximum when phi is equal to 0, and the resultant amplitude is minimum when phi is equal to pi, or 180 degrees. Um, Now there is also, like, they have not given it in your textbook, and you may also not get questions based on this, but just for the sake of completeness, we can also, so we found the A quantity, and now we can also find the theta quantity. So finding theta, it is not a like a very involved process, so I'll just quickly show that also so that you have a complete picture. So theta can be found from these two equations, which is a cos theta and a sin theta. And so if we take ratio of these two quantities, then we are just going to a will get cancelled, and then sin theta upon cos theta will be equal to tan theta, right? So the same trick we are going to use. And then so tan theta is going to be equal to a2 sin phi divided by this quantity, and then the theta is going to be equal to tan inverse of that. So I'm just going to write the same thing. Um, Theta is equal to tan inverse of a2 sin phi divided by a1 plus a2 cos phi. a2 sin phi divided by a1 plus a2 cos phi. इसको भी मैं highlight कर देती हूँ. So this is the resultant phase difference between the resultant phase difference of the superimposed wave, or like the result of superimposition of two waves. And then there is another important concept which is called point of amplitude is always going to be equal to sum of individual amplitudes, because the maximum amplitude will happen when the phase difference is zero. So the phase difference between the two waves is zero, and at that point, if the phase difference is zero, then the resultant amplitude is just a1 plus a2. So summation of two individual amplitudes. So maximum amplitude is the sum of two amplitudes, and the minimum amplitude is the difference of two amplitudes, because the phase difference in that case will be 180 degrees. And the next important point, जिसके ऊपर there are, I saw some questions. It is, yeah. So anyway, so the next point is the intensities of the waves. So this is something that you can just keep in mind, that for any wave, regardless of what type of wave, the intensity of the wave is always going to be proportional to the maximum amplitude uska square. So the intensities of waves are proportional to squares of their amplitudes. Um, so there might be some question where you are asked ki though waves are getting superimposed, then find the intensity of the resultant. So regular question is find the amplitude of the resultant, but in some question they might also ask you to calculate the intensity of the resultant wave. So in that case, a useful relation to remember is intensity is directly proportional to amplitude square. And in case of superposition, the maximum amplitude will be a1 plus a2. So the intensity का maximum value will be a1 plus a2 square, and the intensity का minimum value will be a1 minus a2 का square, because a1 minus a2 is the minimum amplitude that you have. And so intensity is maximum when two waves interfere in phase is constructively, and the intensity is minimum when two waves interfere out of phase. So interfere meaning superimpose. So these two words are like used alternatively in this scenario at least, and usually they are used alternatively. By interference we mean superposition, so that is the principle of superposition. So constructive interference is when they meet in phase, and destructive interference is when they meet out of phase. And now there is like example, we can probably skip this example because it is a fairly straightforward example, and you can also, and the solution is already given. So I have three more examples from the competitive exams based on the stuff that we covered last time and this time. So I can probably just directly go to that slide. You can take a look at both of these examples. I mean, the solution is given and they're also fairly simple. Yeah, so I have started this new notebook for the new chapter, which I will update in the drive after the class. So there are some notes from the things that we discussed in the last class and also from this today's class. And I've put the YouTube videos here, so you can take a look at these YouTube videos also. And then we'll go to the problems. So the first question is very simple, but I just put it to just get started with the problems. So the question is, a plane progressive wave is given by y is equal to 2 cos 2 pi 330t minus x meter. So this is meter, okay? And what they've asked is the frequency of the wave, not the angular frequency, just the frequency of the wave. So this is the equation of wave, and we just have to, what we need to basically do is just to compare this equation with the standard equation of wave. Compare this with the standard equation, which is y is equal to a sine or cos, whatever, doesn't matter, sine omega t minus kx. So somewhere here I might have written the equation also. Yeah, this equation, kx minus omega t or whatever, omega t minus kx, similar things. And so we can take, so the like if we take this cos or sine, it usually matters based on the question. So if the question, let's say, asks for I will just draw a different, or like write in different color. If a question asks to find, let's say, phase difference, then you need to be careful about if it is sine or cos, because sine or cos adds a phase difference of pi by 2. So you need to careful about using sine or cos in the functional form. If the question asks about frequency or even amplitude or yeah, that's all. If the question asks about frequency or amplitude, you can ignore, you can safely ignore the use of like whether it is sine or cos. Because the presence of sine or cos is not going to change the frequency of the object or amplitude of the object for that matter. So in that scenarios, if the question asks about frequency or amplitude, or there might be some another quantity that I'm missing, but you need to check the question, and then if you see find the phase difference, question me, then you cannot ignore whether it is sine or cos. You have to keep in mind, because otherwise, if this is cos and if I write it as sine, then it will add a phase difference of pi by 2. So you need to be careful about that. But since this question asked about the frequency of the wave, so we can safely ignore the difference between sine and cos, and then we can compare this y is equal to 2 cos 2 pi 330t minus x with y is equal to a cos omega t minus kx. So this k is 1 here if you directly compare, and then the omega t is 330. But that is this is a, it might happen by oversight, but if you need to also see this factor and decide where it goes, because here we have a cos and then cos of something, but they have taken out this 2 pi factor common, and it might confuse, or just by oversight you might say that this is omega 330 is omega, but don't do that. So we can write this in correct form, which is cos 2 pi 330t minus 2 pi x. And now we can directly compare that this is a, and this is this entire thing is going to be omega, and this thing is going to be k, and this is x. And we need to find frequency, but that will come from omega. So we'll take omega is equal to 2 pi into 330. And then frequency we know is equal to omega upon 2 pi. So we know that omega is actually equal to 2 pi into frequency. And then this very conveniently 2 pi is separate, so we don't need to even do any calculation. And just by comparing this with 2 pi f, we just directly get the relation that this value is f. And so f frequency is going to be 330 hertz. And so this is going to be the answer. Mm, I'm putting the answer here together so that it doesn't add unnecessary pages. Now coming to second question, this is also from JEE, and this is related to superposition. So the periodic motion represented by equation y is equal to sine omega t plus cos omega t. It is represented by this equation and the amplitude of the motion. So we need to find this amplitude of superposed motion, because this is essentially y1 and this is essentially y2. So we can just compare, and we can just find a1, a2, and phi values. So y1 is going to be sine omega t, or this is just going to be 1 sine omega t, which means the amplitude A1 is going to be 1. So they have not given the units, so we don't need to worry about the units. And the Y2 is going to be cos omega t, and this is going to be 1 cos omega t, which is also going to be equal to 1 So this is where you need to worry about whether it is sine or cos, because this phase difference that comes into the formula to calculate resultant amplitude. If you remember, this formula has phase difference, right? So in such cases, you need to worry. This is essentially the relation or the equation that comes into the formula to calculate resultant amplitude. Hello, am I audible? Can someone confirm?
Yes, yes, madam.
Yeah, okay, yeah. Sorry, my connection dropped, I think.
Okay, okay, no problem.
Let me share again. Hmm, yeah, I hope you can see the notebook.
Yes, madam.
Yeah, okay, yeah, so sorry. Huh. So this will be 2 into A1 is 1, A2 is 1, and then cos phi is just going to be 90 degrees. So cos 90 degrees is going to be 0, and so this term is completely going to be equal to 0. No, yeah, correct, correct. Cos 90 degrees 0. And then 1 plus 1, 2, and this is just going to be root 2. So the resultant amplitude is just going to be root 2. And this is what they're asking. The amplitude of the resultant motion is going to be root 2. So the option B is correct, which is also given here. And the third question is going to be again about the superposition thing. So this is slightly a different question. I will just write the two progressive waves y1 is equal to sine 2 pi t upon 0.4 minus x upon 4, and y2 is equal to sine 2 pi t upon 0.4 plus x upon 4. They are superposed to form a standing wave. So this is the concept that we have not learned, but we can still do the equation, and in the next thing we are going to learn standing waves. You don't need to like know the concept here, but or maybe actually we can just go to standing waves and come back to this question later. um, or actually it doesn't matter, because this is a mathematical question in a sense. I will explain to you guys what is standing wave in the next part, because that is the next section. I did not realize that this is a standing wave question and that we will not cover the standing wave now. But it doesn't matter, because this is a essentially like a superposition question. Standing wave is, it comes from superposition of two waves. So in that sense it is still fine. um, so yeah, just the question is, two progressive waves y1 and y2 are superposed to form a standing wave. X and y are in SI system, so they are in meters. Amplitude of the particle at x is equal to zero point 0.5. So we have to find out the amplitude of resultant wave. So let's just call it capital Y. Amplitude at x is equal to 0.5 meter. Um, so now you can see that this wave is in a slightly different format than the sine omega t wave that we saw here. So this is in omega t format, whereas this is in the omega t minus kx format. So this is in a slightly different this thing, and so we cannot directly use the formula that we had derived for the sine omega t case, but we can very easily derive the new formula on the spot. So this example I took so that you can also figure out if the wave is given in a slightly different format. Then also it is very fairly easy to just derive the entire equation all over again, and it's not a very tedious job. So we are going to do that, and I'll just change the pen color for that. So so essentially we are going to look at again the trigonometric identity sine a plus b is equal to sine a cos b plus cos a sine b. And similarly, the version for a minus b is going to be sine a cos b minus cos a sine b. So these are the two trigonometric identities that we are going to use. The wait, yeah, the resultant wave that we are going to find is going to be a y is equal to y1 plus y2, which is going to be equal to sine 2 pi. I'll just write this as one bracket with minus plus sine 2 pi, same bracket with plus. Um, so now we can use, so essentially this problem is of the form of sine a minus b plus sine a plus b, right? And then we can substitute these two values here, and we can just say what is the outcome of that. So sine a minus b is just going to be sine a cos b minus cos a sine b, and sine a plus b is going to be sine a cos b plus cos a sine b. And these two terms are going to cancel each other because they're plus minus terms, and these two terms are going to be added up, first two terms, and so that relation is just going to be sine a cos b twice, so 2 times sine a cos b. And now we can easily use this relation over here as well to write y as 2 sine a, this is a, this is going to be a, and this is going to be b. So we can write that as 2 sine t upon 0.4 into cos x upon 4. And so this is essentially going to be the resultant this thing of the two waves. And now they have asked for the amplitude of particle at x is equal to 0.5 meters. Mm, there is something, yeah, sorry, I have missed the factor of 2 pi. I told you to not do that, and then I only did that. Yeah, so I'm going to take this factor again. So the a is going to be 2 pi into this thing, right? And wait, are you, um, hello, am I still audible?
Yes, madam, you are audible. Hello. Uh, Students, it seems madam have network problem. We'll wait for some time.
Hello.
Yes, madam.
Yeah, yeah. There's a lot of internet issue here. I will just share the screen again.
No, no, listen,
Yeah.
ma'am. If it is too troublesome, we can stop here. We can continue next class.
Yeah, I think I will cover this one question, and then maybe I will not, because I was going to start teaching again
Hmm.
from the new section, but then maybe I'll just cover this section and then we can continue from the next class.
Yes, ma'am. No problem.
Yeah, yeah. I hope the thing will not drop again. I have switched. Yeah, now this is going to be the resultant. I think this is where I had left off. But yeah, this is going to be the next, the resultant wave of the two waves ka superposition. And now, if you remember the thing about variables, so the variable here is the t, and that term, the term containing t is sine 2 pi t this thing, and that is going to be essentially the thing that denotes the motion. It governs the motion of the body, whereas this 2 cos 2 pi x 4, that is going to be the resultant amplitude. So if we had to write this equation in the form of um, we will come back again to this when we learn stationary waves. So the stationary waves are essentially given in the form of f of t and then g of x. So you can see that form here. So f is sine and g is cos. So sine of t and cos of x. So these are the two separate terms that we get in standing waves. But the theory will come back to later. But here, what we will have is essentially this is the factor that will govern the motion, and this factor will give you the amplitude of this kind of motion. And then we have this sign we will take out, and for this case, we will have the amplitude that is equal to 2 cos 2 pi x upon 4. So this will be the amplitude of this motion, and this factor will govern the motion or like the oscillations, the waveform of this wave. And they have asked for the amplitude of particle at x is equal to zero point 0.5. So we can easily substitute now x is equal to zero point 0.5 here, and this is going to be 2 cos 2 pi into zero point 0.5 is just going to, we can write as divided by 2, and this is going to be 4. So this will be 2 cos 2 to cancel pi by 4. And conveniently, they have also given the value for sine and cos pi by 4. So pi by 4 is 45 degrees. And so this is going to be equal to 2 into cos 45 degrees is 1 by root 2. So 1 by root 2. And this is going to be equal to root 2. So the result will be, or the answer will be root 2, which is this question. So we will come back to what is this equation. I will mark this red so that we can learn about the standing waves thing conceptually, and then we can come back to explaining um, this thing in the next class. So yeah, we will. I think I will stop here, and then I will put these notes on the drive, so you can also take a look at the formula and everything. I will start putting homework questions once we learn a little more of, or like once we cover a little more of things, and then I will start giving questions for your homework. And then I will stop now, and we can continue from here in the next class.
Okay, madam. Thank you very much. Good night, all of you. We tomorrow probably there will not be class because Mangalam sir is unavailable. So next class as scheduled. Except tomorrow class, the other classes will continue. Okay. Thank you so much. Thank you, madam. Good night. Bye. Take care.
Yeah. Bye.
Thank you.